Hi guys, so today we're going to be doing a tutorial. Basically what we're going to be doing is some practice questions to help you guys, build some skill and get used to taking the derivative with the definition of the derivative. So let's get started. Our first question, we're going to start off a little easy. It's going to be, let's find the derivative of y with respect to x of y equals 2x. So let's write that definition of the derivative down. The limit as h approaches 0 of f of x plus h minus f of x all over h. So what do? We know f of x is just equal to y, which is equal to 2x. So the slightly more complicated, but not super complicated part is this part. So f of x plus h. Remember, this is not 2x plus h. It is not. This is equal to 2x plus h in brackets, 2 times bracket x plus h, not 2x plus h. That is incorrect. Remember, I think in previous videos I mentioned a memory trick where you want to think that h is basically the closest to x somehow. Like, it's just x gets affected by h basically first, and looking back at it, it is kind of a stupid trick, but if you find it works for you, it's better to understand what's happening. But if you find that it works for you, then I guess go ahead and use it, but it's better to understand the concept. So okay, let's continue. Let's write this. And so we got f of x plus h is 2x plus h minus f of x, which is just 2x all over h. And we're gonna multiply some things out, and we're gonna end up getting 2x plus 2h minus 2x, because we multiplied that first part out, and we've got some cancellation. 1, 2. We get limit as h approaches 0 of 2h over h. These cancel. So you just got the limit as h approaches 0 of 2. And because since all the h's have canceled out, this is just 2. Super easy. Not that hard. Do a harder example. But yeah, so maybe we can illustrate this with what we just did, the meaning of it. I'll elaborate a little bit on that with an example. I mean, not an example, a drawing. So let's do a sketch. So our function was y is equal to 2x. Sketching that, we have some line through an origin. Now recall, the equation of a line is y equals mx plus b. Comparing that to this, we see since it goes to the origin, b is equal to 0. But we have our slope m. Well, by taking the derivative with the definition of the derivative, what did we get? We got y prime is equal to 2. We just got the slope of the line. Now, okay, so recall the tangent line to this linear line is just itself. If I pick a point here, the tangent line is just, well, the line itself. Pick a point here, same tangent line. Or you just got the slope of the tangent line, which is just this. It's just this. You took the derivative, you just got the slope of the line. Cool, right? Now, how is this different from in our last video, we did something with the parabola. Now, notice, when we took the derivative of y equals x squared, we got 2x. Well, here you got a constant when you took the derivative of 2x, of this expression right here. Here you took the derivative of x squared and you got 2x, which was a function on its own. And look at this. The tangent lines at different points have different slopes. You got like negative slopes here, you got positive slopes here, you got steeper slopes here, you got shallower ones here. You got different slopes at different points. The slopes of the tangent lines aren't constant. They're not the same at different points on the graph. Hence, you have this x here, this variable. You plug in a different x value depending on which point you have on the parabola, you get a different slope for the tangent line. Cool. Keep that in mind. That's very, very important, the difference here. Here you just have a constant. The slope of the tangent line is always 2. No matter where you are on this continuous linear function. It's also going to be 2. Okay. So let's move on to, that was an easy example. Let's do something a little more complicated. A little different too. So let's say our function is y is equal to root x. Okay, that looks very different. Let's start. Let's write our limit. Our definition of the derivative. H approaches 0, and we got our f of x plus h minus f of x, and we got the all over h. And so, okay, what's our f of x? Our f of x is root x. Now, this part, f of x plus h, once again, I will point out, in this case, f of x plus h is not root x plus h. It is not. F of x plus h is root x plus h. Not this. Okay, so let's put everything together. We got our limit as h approaches 0 of root x plus h minus root x all over h. Okay, now this is not as easy to evaluate as, the other examples we've done previously. But how do we evaluate this limit? So notice something cool here. We can multiply by the conjugate. Yeah, the conjugate. So let's multiply by the conjugate. Let's see what happens. Actually, let's erase this, move it upwards. So let's write that out. We got the limit as h approaches 0 of x plus h minus root x all over h. So let's multiply by the conjugate. And so we got, what do we have? We have root x plus h plus root x all over, again, x plus h plus root x. Multiply this out. What does this become? We got this this multiplied out. We got limit as h approaches 0. And so what happens is that we got rid of the square root signs on the top. This is what we got now. Simplifying this entire expression, multiplying everything out. What did we get? We got this. Now we got some cancellations. We got this. We got 2x to cancel out. And let's keep going. Now it's just about some cancellations. I like to go through the cancellations a little slower because I don't want you to miss them. They're very important. So these h's cancel. You see how your pre-calc skills, they really come in use. You really got to be sharp in pre-calc if you want to do good in calculus. So, okay, so let's write down our simplified expression. We got our x plus, let me write that a little neater. We got our x plus h plus root x. Nice. Let's take the limit as h approaches 0. So h goes to 0. What are we left with? Quite easy. H approaches 0. 1 over root x plus root x. And this just gives us, well, h approaches 0. So let me rewrite this. So, wrong. 1 over root x plus 0 plus root x. So you can see that better. And what is this? This is just 1 over 2 root x. Because this is just root x plus root x now. Right? Because, well, h approaches 0. So what did I get? My final answer is 1 over, well, half 1 over root x. Or 1 over 2 root x. Cool. We did a slightly more complicated example. But so far, all we've been doing is dealing with, single terms. Like, we just got this one, like, we got x or we got 2x. How about we deal with something a little more complicated? Let me erase this. Okay. Let's deal with something a little more complicated. Okay, so let's say f of x is equal to x squared plus 2x plus 1. Okay, this is multiple terms, so let's write down our definition of the derivative. Once again, always writing that down so we can, group together the terms. We write that down, and f of x, easy stuff first. F of x is just, x squared plus 2x plus 1. And now the slightly more complicated part. F of, erase that, f of x is equal, not f of x, f of x plus h is equal to, well, let's actually talk about what it's not equal to. It's not equal to x squared plus h plus 2x plus h plus 1 plus h. Actually, this part doesn't even make any sense because there's no x terms, but whatever. It's not equal to this. It's not this. Not. Do not make this mistake. I've said it so many times. Just do not. Okay, so what is it equal to? F of x plus h. So looking at each term, x plus h all squared plus 2 bracket x plus h plus 1. That's what it's equal to. So it's, plus 1. Okay, let's put it all together. The limit as h approaches 0. So let's put that in, f of x plus h. So we got x plus h squared plus 2x plus h plus 1 minus bracket x squared plus 2x plus 1 all over h. Notice please, you have to be very, very strong in your algebra skills to do well in calculus. A lot of students, common mistake, what they do here is they just say minus x squared plus 2x plus 1. No, that is not right. If you're going to put that minus, it's going to be bracket. Because you got to FOIL this basically -1 to each term. Keep that in mind. You have to be very strong with your algebra. So let's rewrite this again. Just move this upwards a bit. So what we had was the limit as h approaches 0 of, we had x plus h squared plus 2x plus h plus 1 minus, I'm going to erase this, minus x squared plus 2x plus 1 all over h. So let's FOIL this out. Not too hard. Again, you gotta rely on those strong pre-calc skills. So x squared plus 2xh, we're gonna FOIL this term out, plus h squared, and we're gonna distribute that 2 in the second term. So we're gonna get 2x plus 2h plus 1. And then we're gonna, subtract x squared. Remember this sign right here. Gotta distribute that -1, so we're adding the negatives of these. Minus 2x minus 1 all over h. So we got a lot of cancellation here. We got this x squares canceling out. We got the 2x canceling out. We got the 1s. And now we're going to rewrite this. Always looking for those good cancellations. So what's left? Now we got some h terms canceling out. Right there. Nice cancellation. So what does this become? This is limit as h approaches 0 of 2x plus h plus 2. H approaches 0. What is this? This is just 2x plus 2. This is our y prime. Our function that gives the slope of the tangent line at different points on our original function, y is equal to x squared plus 2x plus 1. So also it's our dy by dx. So, ta-da, we have our derivative. So, cool stuff. the key to doing well in the derivative section is to do a lot of practice. Do the even and odd questions in your textbook. I know a lot of textbooks, they only cover the odd answers, but you can always find even answers online through different sources. Sometimes you have to do some digging or ask your professor, because a lot of the even questions in the textbook tend to be more challenging, and they build your skill much better. I'm gonna leave you guys a question. I'll release the answers, but you can put it in the comments what you get as the answer. So I'm gonna leave it for you guys. So this is our function plus x cubed plus root x. I want you guys to find the derivative and leave it in the comments, and I will confirm if your answer is correct or not. And I want you to use the limit definition of the derivative. So pause the video, do this question. It's a very good one. It'll test